So as I always say, I would like to say thank you everyone for coming. This webinar, we're really going to focus on Onshape Assemblies and all the details you need to make up your assemblies and test the motion out in Onshape. So we're really going to focus on the assemblies aspect of Onshape today and all the different details of it. As I always say with these webinars, I really encourage you to ask any questions that you'd like. So feel free to type in any questions into the questions dialog in your GoToWebinar control panel. I'll do my best from time to time and stop and address those questions. If I don't get to your question, stick around. I'll do my best to make sure they're all addressed before I end the webinar today. So again, thank you everyone for coming. We're really going to focus on assemblies and the assembly modeling in Onshape today. So let's dig in. Now, there are a few things I always like to show about Onshape in general before we get into the topic of the day. And one of the first is our mission statement, and that is getting everyone working together with CAD on any device, anywhere. And so if you haven't used the Onshape mobile app, if you haven't shared your document yet, a lot of the benefits of Onshape really come in when you start doing these types of things. So definitely check out the Onshape app. It allows you to not just view your models, but actually build real 3D models from an iPhone, an iPad, or an Android phone or tablet. So you really do have a lot of flexibility. You can work anywhere. You have accessibility to your CAD data anywhere. And you can also work together. And what I mean by that is simultaneous real-time collaboration with comment capabilities and follow mode, and all these neat things are built in to allow you to work with other people. So if you haven't shared your document yet, if you haven't checked out the Onshape apps, I definitely recommend it. Very much ties in with our theme, and that is getting everyone working together with CAD on any device, anywhere. Now, the other thing I always like to point out about Onshape is we do consider ourselves professional 3D CAD. And when you think of professional 3D CAD, it's really three pieces. It's parts, assemblies, and of course drawings. And we do have all three major pieces that make up a professional 3D CAD system. Some things that about Onshape that are unique, you'll notice, is that we update very frequently. So you're going to see new functionality being added to Onshape roughly every 3 weeks. New functionality, new features. And the neatest thing about it is you don't have to do anything, right? It's because we're a web-based service, you just log in and you have new functionality. There's nothing that you have to do on your part. So we do have parts, assemblies, and drawings, and you'll see them evolve very quickly. We're moving at a very rapid rate. Some other things I always like to point out is with Onshape, version control is built in. So if you're familiar with traditional CAD applications, often that's a separate application, a separate data management tool or something that you have to install and manage separately. With Onshape, that capability is built into the core. So you can manage versions. We even have history functionality that allows you to do all of this without an additional software application or having to manage something separately. So it's all built into the core functionality of Onshape. Now, for those that are new to Onshape and maybe you have experience in other CAD systems, or maybe you have a library of CAD data, realize that we can read and write a lot of the traditional CAD formats that are out there today. So STEP, IGES, Parasolid, SolidWorks, Inventor, Creo, CATIA, I could go on of all the different formats that we import and export, but definitely check it out. We work very well alongside many different CAD systems because of this ability to import and export CAD data to a lot of different formats. So even if you're not using Onshape every day as your professional tool, there's a lot of scenarios where you can use Onshape as a collaborative tool, right? Because of our ability to work with all these imported files. And of course, it's also a great tool for sharing because it allows, the user to export in whatever format they want. So I can import a SolidWorks part, for instance, and export it as an IGES or a STEP, Parasolid, whatever it may be. So works really well alongside existing CAD systems because of this ability to read and write common CAD formats and, of course, the built-in version control. The last thing I want to mention, I've already briefly discussed it, is new methods of collaboration. If you haven't shared your document yet, I definitely recommend it. There's a big share icon in the top right corner. You enter their email address, define their permissions, and hit share. So it's really simple to do. It just takes a few seconds. Even if they don't have an Onshape account, we create one on the fly for them. So it's very easy for you to share a document with someone who's never heard of Onshape. And within a minute, they could be looking at the same model you are. So entirely new methods of collaboration. And it's not just sharing. You have the ability to collaborate in real time. So now 2 or 3 or 10 people can work on the same assembly at the same time. Or I can be in the same document at the same time. So you don't have to worry about check in, check out, or who has that file, or any of those kinds of concerns. All of that really goes away with Onshape's collaborative benefits. So definitely worth checking out if you haven't shared your document, if you haven't been shared in a document and checked out all of the simultaneous collaboration and comment capabilities and follow mode and all the neat things we've built. I definitely recommend it. So those are just some things I like to mention about Onshape in general. Let's get into the topic of the day. And of course, the goal for today is kind of the basics of assemblies. How do we get started building an assembly? How do we handle mates? How do we handle motion and setting all those details up? So that's really what we're going to focus on today. Starting your assembly and how to add mates and get everything pieced together. So that's the goal. Now, an important part of this is what we call mate connectors. I'm going to get into a mate connector in just a bit, but it's an important thing to point out as we're going through this that in Onshape, the mates are dependent on mate connectors, and it's a very fast way to assemble models. And if you've come from a traditional CAD background, it is a bit different, but once you get the hang of it, it's a much faster approach. So we'll get into that in just a bit. The last thing I want to mention here today is we are going to get into some relations as well. So things like gear relations and rack pinion relations and so on. Just giving that, little bit more realism out of our assemblies when we have, things that drive other components, for example. So that's really the rough outline for today. That's our goal. Not really, maybe not a full hour, but definitely a lot to cover. So let's jump in. Now, as I mentioned before, feel free to ask any questions that you'd like. I have the questions up here. I'll do my best to stop and address them. If I don't get to them, I'll make sure to get to them before I close the webinar out here today. So again, feel free to ask any questions. Okay, so let's dig in. Now, the idea here today, we're going to jump right into the software is, how do I get started in my assembly? So maybe I've done some basic part modeling, but I'm ready to start building my assemblies. How do I get started? So let's jump out of the slides, and I'm going to jump right into Onshape. Now, we're going to start from scratch in terms of an assembly. So I'm just assuming that maybe you've built a few simple parts and now you're ready to piece all this together and test out the motion. The important thing I want to point out, and I want to stress this though, is assemblies are about motion. They're all about motion. If you don't have movement in your assembly, many users will not even create an assembly. They'll work entirely in a part studio because there's no movement. So it's an important thing to point out. You can model multiple parts together in a single part studio. And I'll show you an example in just a second. But the key thing I want to stress is if your assembly doesn't move, it may not even be necessary to build an assembly. The assemblies are really about motion. So I mentioned before, well, what if my assembly doesn't move? What options do I have? And the reason I like to point this out is in Onshape, you can build multiple parts together. So here I have a pneumatic clamp, right? And there's a series of parts modeled, all in context, relative to each other. And the beauty of this is, A, it's very easy to build parts relative to each other. I don't have to take a bunch of measurements. I can convert entities and so on. So there's all kinds of neat benefits in terms of modeling. But also, if there's no motion, I can build everything as a static part studio. So again, just kind of stressing the idea, if there's no motion, you may not even need to build an assembly. Just work in a multi-part studio. But again, that's a matter of preference, so we can move on. The thing I want to stress here again is, as we're going through this and getting into the motion elements of it, just realize that, for many users out there, it may not even be necessary. So maybe you've modeled a few parts. So here I've got this finished swing arm, single part and a single tab. And if I jump over to the next tab, of course, I've got the pneumatic components that I was just referencing. That is 3 parts in this one tab. But now I want to take the finished swing arm and these 3 parts, and I want to bring them together and test the motion out, and put them together and move things around and make sure that it's behaving the way I'd expect. That's when we get into assemblies. Now in this case, I have an assembly. If I click on the tab here, but it's blank. And so this is what you're going to start with. When you first get started, you get a blank part and a blank assembly. And as you start building things, you'll then want to jump into that assembly and start inserting and mating and so on. So I've built a few parts, in my case just 4, and I want to insert them into the assembly. And so of course the first thing I want to stress here is, how do I get started? How do I decide where to insert parts and, how I should get things rolling here? And so one of the first things to know, of course, probably one of the most important when we're talking about assemblies, is the insert command. All right, so I can insert parts or subassemblies into this assembly. And that's the very first icon in the toolbar. And you'll see insert parts. If I click it, I get a little flyout listing all of the parts in this document. Now, we have parts and we also have assemblies. Now, in this case, there are no subassemblies, but if you have an assembly with maybe a few subassemblies within it, you have that option to insert that as well. Okay, so just keep in mind, you can insert parts or other assemblies. Now, in my case, I want to start with those pneumatic components that I was just showing you. Now, in this case, as I mentioned before, there's three parts there. There's a cylinder, a plunger, and an O-ring. So remember, that one part studio had three parts in it. In my case, I want to insert all three. And the neat thing about modeling it this way is if I left-click the part studio, it will insert all three parts at once. So it's another big advantage of that multi-part modeling, building parts together. I can insert them all together into my assembly. So I select the part studio from the list. You'll see the part studio highlighted here. I hit the green check. And now those three parts are in my assembly. So that's going to be your first step, inserting the part or subassembly into your assembly. Now, at a glance, it looks like this is done. And a very important thing to point out is it's not mated. And that's a key thing in Onshape. When we first bring these parts in, they're quote-unquote free-floating. If I grab and drag, these things will move around anywhere on the screen. So that's when we start to talk about constraints. So real quickly, a couple questions here. Forgive me. Can you insert parts from other documents? A very good question. The answer today is no, but this is probably one of our biggest priorities as of today. So I expect hopefully to have that capability very, very soon. Now, it's worth pointing out you can copy a part from one document to another. You can right-click a part and say copy to clipboard and paste it. However, it's not true linked parts from other documents, and I think that's what the users expect. That's what we're going to have very soon. But as of today, unfortunately, no. Okay. If we insert a subassembly, will it still have mates, which we applied while creating that assembly? Absolutely. So if you insert a subassembly, the mates from that subassembly carry over to the top level or to the next level. A very important thing to point out. In some traditional CAD applications, that's not the case. So when you insert a subassembly into a top level, it comes in as like a rigid object. Sometimes it's referred to as rigid versus flexible. You might say in Onshape, all subassemblies are flexible. All the mates in the subassembly are respected. So very important thing to point out. Very good question. All right, so let's jump into this next step here. As I mentioned before, it looks as though these things are assembled, but they're really not. You know, I can move things around and they slide all around in my assembly. So the first key thing is, you know, how do I want to start constraining this thing? And one of the first tips that I have is, what is your fixed part? You want to define a fixed part to assemble everything relative to. And if you think about most assemblies that you piece together, one part is fixed, and then you start piecing together all these things around that one piece. I give the example of a traditional gas engine, where the engine block would be the fixed part, and then you have the crank and the rod and the pistons. All those parts move relative to the engine block. So in that case, the engine block is the fixed part. Well, if you look at our case, I have this cylinder where the plunger slides up and down, the O-rings here, but in reality, the cylinder doesn't move. Everything kind of moves relative to the cylinder. In that case, I can fix the cylinder. And the first thing I'd recommend when you first insert your parts into your assembly is define what is your fixed part and fix it. And the way you can do that is right-clicking the part, either in the graphics or the feature list, and choosing Fix. Okay. You'll notice a small little indication here that the part is fixed in the assembly. So there's a little icon here. Now that cylinder does not move. Right? If I drag it, it does not move around the screen. It's fixed in its current location. So that's one of my first tips. When you're getting started with your assembly, make sure to fix your defined part, whatever that is. Now, it's important to point out, I fixed the cylinder, but the plunger and the O-ring are not fixed, right? So they are, again, free-floating. There are a few things to point out here, but one of the first is, as you're getting started and you start building your assemblies, it's important to realize you may not even have to mate certain parts. So an example of this would be the O-ring. In this example, I have this O-ring that I've inserted into this assembly. But in this case, the O-ring doesn't move, right? It's fixed relative to the cylinder, and it's already in the correct location. So another benefit of building all these parts together is that I can group parts together and act as a single thing. And the big benefit of that is it's way faster than going in and manually applying mates to constrain something that would otherwise be fixed. So an example of this is the O-ring, right? The O-ring is moving right now, but in reality, it should be fixed in its current location. So I can use the group command and group the cylinder and the O-ring. And the benefit of this is now the O-ring is not underdefined. It's constrained. So keep in mind, you may not have to mate it. And there are many situations in Onshape where you may have a gigantic assembly with hundreds of parts and only 2 or 3 mates. You know, it's really all about the motion, and the motion defines the number of mates that you need. So you can group a lot of parts. I can group several parts or dozens or hundreds of parts together at one shot, and it makes it very easy for me to decide, okay, these are all fixed things, and these are the elements that move, and that's what I need to mate. Okay? And the big thing here is it means that oftentimes you may only have 2 or 3 mates in a single group instead of a list of 100 mates, you know, to tie everything down. Question. Can the icons be made larger, easier to see? Forgive me, I believe there's a way, I believe there's a keyboard shortcut. Stick around. I'm almost certain there's a keyboard shortcut that will enlarge the toolbar icons. This is also an area we hope to improve soon in terms of general usability, but there is a keyboard shortcut that will do that. Just forgive me off the top of my head, I'm not remembering it. Okay, so I've inserted my 3 parts, and I've grouped the O-ring to the cylinder, right? So these parts are not going to move, and they're fixed. But the plunger needs to move. So it's important to keep in mind, anything that needs to move needs to be mated. So keep in mind, as you're doing this, it's all about defining what is the movement. You know, what constraints do you need? So as I move this plunger around, you'll see it's really just free floating, right? It'll move anywhere that I move it. What I want to do is, of course, I want to locate this plunger inside of the hole in the cylinder. And I want it to be able to move up and down inside of that cylinder and spin if it needs to, right? So that's where we get into mates, right? The movement. Now, one thing that I want to point out about Onshape that's a bit different than a lot of traditional CAD applications is you can oftentimes eliminate combinations of mates with Onshape because we use a little bit different process. And that process, a little bit higher level system of mates, is using what we refer to as mate connectors. Now, the way to think of a mate connector is a point. So if I take a point from this part and a point from this part, and I bring those 2 points together, and then I define the degrees of freedom, how much movement there is, based on the type of mate that I choose. So that's really the key to Onshape mates, is these mate connectors and bringing them together. So let me walk you through this. Now, the mates are right here in your toolbar. Right? So these series of icons here, including the tangent mate that's newly added. And we have a few different mate types. I'm going to go over an example of each one of these, so bear with me in just a bit. But I'd like to start with a cylindrical mate. So a cylindrical mate allows me to rotate and move up and down. So I'm going to select cylindrical. And as I move my cursor over the plunger, notice these white dots appear on the part. And these are the points that I was referring to. And oftentimes you'll hear people refer to them as a coordinate system, and that's fine as well. But I like to think of them as just a simple point. You know, I want to bring this point in the center of the plunger, and I want to mate it to this point on the bottom of the hole in the cylinder. So all I'm really doing is bringing those 2 points together, and then the movement is dictated by the type of mate that I have. Now, in general, a tip that I have is you can try out different mates, right? You're not forced to exit the command and go select a different icon to do a different mate type. So here's cylindrical, but if I wanted to flip the mate to slider, for instance, it's very easy to do. Just select a different one from the dropdown. The reason I bring this up is it's a great way to learn the mates, because you can hit play and animate the degrees of freedom and get instantly visual feedback as to how much movement you're getting in this assembly. So I can see as I hit play, it spins and it moves up and down. So that's the motion that I'm allowing with this mate. What's neat about this is I can switch the mate. I can say, okay, let's take a look at a slider mate and hit play. And I can see now it's just moving up and down. It can't spin, right? So an important thing to keep in mind, you can try out different mates, and it's a great way to learn what the mates do, what kind of behavior you'd expect from a certain mate. So a slider mate just gives you that one linear degree of freedom, right? It can move in and out, but it can't spin. The cylindrical mate allowed it to move in and out and spin. Another example I might show is something like a ball mate. A ball mate is all rotational, right? So it rotates in all different directions. And obviously not what we're looking for here, but again, just trying to illustrate that you can go in and try different things out. So in this case, I want this to be a cylindrical mate. I hit the green check OK. And now I've added a cylindrical mate in my feature list. Now, a question often comes up, how do I edit or how do I change a mate after it's been created? You go to your feature list and edit. And you can even go into the mate connectors for each individual mate and edit them as well. Right? So the mate is listed here in the feature list. If you need to delete or edit or anything along those lines, you can right-click here to do so. But now, of course, the main goal with this is, well, what does it look like when I move it? So if I drag this up and down, you'll see it moves like I'd expect. I can't drag it left to right? It doesn't allow me to go in either direction that way, but it is allowed to go up and down and rotate. So ultimately, that's going to be the test. When I grab and drag, what happens? Does it behave the way I'd expect? So now I've inserted this cylindrical mate, and now the plunger is mated inside of that cylinder. Now I want to move on to the next step. Before I do that, just real quickly, quick question. Is there something that limits the actual translation? And the answer is absolutely. We have a limits option. So when you're in a mate, you have a limits checkbox. Now you'll need to determine the range of motion. So it does not detect when another part hits another, for example, but you can drag and dynamically change and actually see the value. I don't know how clear it's going to be through the GoToWebinar, but there's actually a little number that appears in the graphics there. And so it is easy for me to determine the range of motion and then enter a minimum and maximum value. And that will restrict the range of travel. Now, as of today, there's no way to say stop when it hits another part, for example. So that's another question. Is there a stop on class, for example? And the answer is no, not as of today. But you can limit it. You'll just need to figure out the minimum and maximum value. All right, so I've got cylindrical in. The next thing I want to do is I want to insert the arm, the finished swing arm. So just jumping back real quickly to that tab, I want to insert this part. Right, so we've already inserted the other three. Now let's move on to this one. So I'll jump back to my assembly. And again, I'm going to go back to insert parts. Okay. So I select insert parts, and I select the part I want to insert. Now, a quick question that's come up, can we enter negative values and limits? You will have, it's important to keep in mind, you do have the option to do negative limits. You want to make sure that it's a minimum or maximum value, and that makes sense. It's also a key thing to keep in mind. You can spin the mate connector around to where what is positive is now negative and vice versa. So if you're not getting the correct behavior with a negative value, try flipping the mate connector and then to where that value would be positive. That's also an option. So just something to think about. You can enter negative values. I think the one exception to that would be like an angle value. So forgive me, not all situations, but in the last example I just gave you, yes, you could use a negative value. But an alternative would be to rotate those mate connectors and get everything lined up that way. And I'm going to go over that in just a bit, by the way. Okay, so I've inserted my finished swing arm. So you see that part has now been inserted into my assembly. And again, it's not constrained in any way. So if I left click and drag, this thing moves all around. One thing I like to point out is the triad in an assembly. So if I just left click and drag, it moves around. But what if I wanted to rotate about the X? Or what if I wanted to move along the X, for example, or the Y? If I left click a part, you'll see a triad appear that allows me to grab and drag. So I can grab and drag along an axis or rotate along an axis. So you have a lot of neat options if you're looking for a little bit more control over the rotation elements or any of those kinds of things. Just left click the part and then grab one of the arrows or circles here and just manipulate. Okay, very simple to do. But of course, my goal with this is to assemble this finished swing arm on top of the plunger. Now, this is an example if you've come from a traditional CAD application where this might take a combination of mates, 2, sometimes 3 mates to position this part on top of the plunger and orient it or clock it. Sometimes that's referred to where I set the angle. That can be a combination of mates, 2 or 3 different mates in a traditional CAD application. What's really unique about Onshape and our approach is this is something that can be done with one mate, what we refer to as a fasten mate. Now, the reason this is so important is think of mating a bolt to a hole, for example. And this is another example where I might use a combination of mates. I might use something for concentricity and something to align planar faces and something to set the rotation angle. And again, a combination of mates. With Onshape, it's one fasten mate. So I select fasten, I move my cursor over the top of the plunger, again, just waking up that point that I want to reference. Then I'll move this over the top of the swing arm, and it brings the two together. That one mate, the fasten mate, restricts all degrees of freedom. So the finished swing arm cannot move relative to the plunger. Now, the example I like to give again is the bolt. If you have a bolt and it needs to go into a hole, it doesn't need to rotate, spin, or move in any way. So a fasten mate is a great example of this. And again, it's just one mate. So if I hit the green check OK, I now have one mate that's attached that finished swing arm to the end of the plunger. Now, the question often comes up, well, what about setting the rotation or that clock angle of the part? And you can do that, if I edit the mate here, with the reorient secondary axis option. So you have reorient secondary and primary axes options. And the secondary will increment in 90-degree increments and give you 4 potential options for how you want to align it. Okay. Now you have more control of this. I'm going to go over that in a second. But you can set it in 90-degree increments very easily here. Another question that often comes up is, well, what if it's aligned incorrectly by default? Now, you can flip the primary axis as well, and that will flip the alignment of the mate to the other side. So just a tip, if it's defaulting to the wrong way, you can always clean that up. Okay, real quickly, a question. Does it matter what mate connector we select first? And the answer is no. No. In the case of mates, it doesn't make a difference. You can select either first, and it wouldn't make a difference. Okay, so now I've attached my plunger to the end of the finished swing arm. I've set the clock angle to what I want. Now, let's just say I accepted it, but you know what? I want to rotate it 30 degrees, right? And that wasn't one of the options when I went to reorient. I only have those 90-degree increments. Remember that you can go in to any of the mate connectors and edit them. So if I go into the feature list here and I edit this mate connector, I can move it. And more importantly, I can rotate about Z and let's say 30, enter, and now I've rotated that 30 degrees. So just keep in mind, you have kind of infinite control over the angle by editing the mate connector. Also very useful, and another commonly asked question is you can actually align the mate connectors with references from the model. So if I want the X along this edge, for example, I can do that with the realign option. But you do have the ability to change the mate or edit the mate connectors after the mate has been created and tweak things and give you a little bit more control. So now we've created 2 simple mates. I have a cylindrical mate and, of course, a fasten mate. Now, the fasten mate restricts all degrees of freedom with the one mate type, but the cylindrical mate means that my plunger can still move up and down. All right, so we've covered the first 2 mate types that I want to discuss here today. Let's move on to the next one, and that is a slider mate. Now, in this example, I have a simple vise that I want to assemble, and there's a few things I want to show with this example. This is a good model to show a number of different mate options. One of the first that I want to point out is the slider mate. Now, the slider mate allows you to define 1 linear degree of freedom. And the reason that's so important is oftentimes you may have, a single direction that you want to travel. And in that situation, a slider mate is perfect, right? So in this case, I've selected 2 linear edges, the edge of the jaw and the edge of the vise base. I define them as a slider mate, and when I hit play, notice that the jaw is allowed to slide along that edge. So it's 1 linear degree of freedom that allows it to move up and down along the edge that I've referenced, right? So a great example is this machine vise where I need to attach it to an edge and allow it to move in and out, but that's it. So slider mate, again, 1 linear degree of freedom. Now, there's another example I could use here, and that's what's referred to as a planar mate. So that's a slider, again, one linear degree of freedom. The planar mate is a little bit more free in the sense that you're really only bringing two flat faces together. It's free to rotate in any direction and move linear in any direction except for, of course, apart. But all we're really doing, the way to think of it, is bringing two planar faces together. So let me show you an example. I'll select planar mate from the list. I'll rotate the part. We'll select the bottom of the jaw, right? The bottom piece of the jaw and the top of the base here. Again, just selecting a point from each part brings them together. Now those two faces are together. They're touching. But it's worth pointing out that's the only thing that this mate does. If I hit play, you'll notice that jaw is free to rotate and move in any direction as long as those two faces are still aligned, right? They're still touching. So the planar mate, again, is a little bit more free, but if all you're trying to do is align two faces, that's an easy way to do it, right? Now, in this case, it actually works for me because I have another mate that I want to add in just a bit to attach the spindle to the jaw. So I'm going to accept that, green check OK, and I've got my mate. Now, as I mentioned before, that's not enough in this case. It'll move in any direction that I want. So I want to mate this cylinder here, this spindle, to the hole in the vice jaw, right? And I want to do this with what we refer to as a revolute mate. So just to recap here, we've covered cylindrical and fasten, slider and planar. The revolute mate allows you to rotate, but nothing else. So if you think about the spindle in the vice jaw, it needs to be able to spin inside of that jaw, but it needs to be attached to the jaw. It can't move relative to it. So this is a great example of revolute. I select revolute. I move my cursor over until I attach the point at the bottom of that hole. Right, I'll select that point, rotate it around. I'll select the end of the spindle, just like that, and the two are mated. Now, at a glance, this looks like something bad has happened. And what's happened is the jaw has shifted. You may have noticed it rotated a bit there. It's important to point out with Onshape, we're only solving for the active mate, the mate that you're currently in. If you want to see it solve for all mates, you hit the solve button in the mate dialog. If you hit solve, it will solve for all the mates in the assembly, and you'll get the correct preview, right? Now, even if I were to accept the mate, it then solves for everything. So this is really just about getting the correct preview. But if you want everything to look correct before you accept it, just make sure to hit solve first. Okay. So green check OK. And now I've got a spindle that's attached to the end of the jaw. But most importantly, I can still spin the spindle, right? So it's still free to move inside of that jaw. Right, so key to it, realistic motion here. Okay, so now we've covered the revolute mate. Again, one rotational degree of freedom. It's allowed to spin, but that's it. What I'd like to discuss next is what we refer to as the pin slot mate. Now, the pin slot mate has a few different neat examples, but the example I always like to give is something like, I have this socket head cap screw, and it locates inside of this slot. Now, the socket head cap screw needs to move in and out to line up with the necessary holes in the table. So it needs to be able to move, but it needs to be able to move in a single direction, right? And this is a great example of the pin slot mate. So I can select pin slot, and we'll rotate things around a bit here. I'll select the mate connector at the bottom of the bolt. Let's grab the bottom here. Right there. And I'll select the mate connector at the edge of the slot. Okay, right there. Now, an important thing with pin slot, I'd say in general I would do this, but even more importantly in the pin slot mate is you need to animate. It's very easy for this to be aligned with the X and not the Y, for example, and for it to go the opposite direction. So something like this, for example, where you'll notice it's free to move, but it's moving in the wrong direction relative to my slot. So you may need to reorient the secondary axis until the movement is like you'd expect. Okay? So again, that's the pin slot. It allows it to rotate, and it allows it to move in a single linear direction. A great example of, I need to locate a bolt inside of a slot. Okay. And I mentioned before, you can add limits. If I check limits, for example, I can say, okay, the minimum is 0 and the maximum is 0.625, for example. And so you can actually restrict the motion. If I hit play here, it'll actually stop once it hits that 0.625. So I can limit. I know I've already briefly mentioned this. I just wanted to show you an example of it. But if I wanted this bolt to stop inside of that slot, I check a limit and then define my minimum maximum values. Okay. Green, check OK. And now we have a bolt mated to the slot. Okay. So that is the pin slot mate. We have one more mate in my list, and that I shouldn't say one more, two more, a ball mate. So another very common one. Now, the example I like to give with this one is a swivel. And there's a few examples I could give, but I think the most common is a swivel scenario. So, here I've got this swivel and, of course, the eye that goes with it. I want to mate the swivel to the eye. But, of course, a swivel needs to be able to rotate in all directions. It can't move in a linear direction anyway, but it needs to be able to spin in any direction. So that's a great example of the ball mate. So I can select ball mate. I can select the center point of the swivel. We'll choose the center point eye here. Notice that only that part carries over. This is another example where solve will solve for all the active mates, and it'll shift all those parts over. So again, if you're in the mate and something doesn't look quite right, try hitting solve and see if the preview looks correct. But that's it. I brought those two mate connectors together, green check, and now I have a swivel behavior. Notice it's free to rotate in any direction. Now, there are two places where we don't have a limit, and that's right now it's fasten. Of course, fasten restricts all degrees of freedom, so a limit isn't necessary, but also a ball mate. We don't have an option to limit in a ball mate. But that's it. You have a real simple swivel example. And again, the key to all of these mates is bringing those mate connectors together, taking a point from one part, a point from another part, bringing them together, and then defining degrees of freedom based on the mate type. So those are all the simple mates. I'm going to go over the tangent mate in just a second. That's relatively new. But all the mates we've covered up to this point really work in the same way. You bring the mate connectors together and then define degrees of freedom based on the mate type. But what happens if you don't easily have a point to select? For example, here's a custom mate connector example with a spring, and there's no good reference here. What I'd like to walk you through is an instance where we create custom mate connectors. Now, real quickly, a question that's popped up. How to animate all the mates at the end of the assembly. Right now, the only way to move things around is with a drag or triad. There is no animation tools built into Onshape as of today. That's another one that's very high on our list of priorities. But right now, you're just moving based on left-click drags or using that triad manipulator to grab and move the assembly around. So back to this example, what happens if I want to mate the spring to the shock? All right, if I go to choose fasten and then I start moving my mouse over geometry here, I don't have a good point to pick. I don't have a reference to select. And so what I'd like to show you is custom mate connectors. And custom mate connectors are kind of like the Swiss Army knife of assemblies in that you can do almost anything with them. And you can create a reference to anything and use it as a reference for your mate. So it's a very flexible tool that allows you to accomplish almost anything. So let's walk through this real quickly. A question. Are there some part mate examples in a library or tutorial where we can play with the mating aspect without having to create a set of parts? What I would recommend is under the tutorial. So just real quickly, is there part mate examples in a library or tutorial? If you go to tutorials in Onshape and the filters on the left, there's an assemblies document there, an assembly tutorial. You can copy that document, create your own version of it, and walk through building mates. So that's what I'd recommend. The tutorials filter in the documents. You'll see tutorials and samples. And there's one specific to assemblies. Okay, so back to my example here. I want to mate the spring to the shock, but I don't have a good mate connector. So what do? I insert one. Now, you can create one in the assembly. You'll see a mate connector command here in the toolbar. Very simple. But I want to create my mate connector at the Part Studio level. And the reason for that is because if I insert this spring somewhere else, I want the mate connector to go with it. If I insert the mate connector at the assembly level, then it is attached to that assembly. And it doesn't help me if I insert this spring into other assemblies. So what I'd like to do is open this spring and add the mate connector. Now, a tip, and this is a big tip for those doing a lot of assembly modeling and jumping back and forth between part and assembly. If you right-click a part in an assembly, you have a switch to option. So I can say switch to bumper spring, and it will switch to that part studio. It's a very quick way to jump into the part studio and make some changes without having to hunt down the tab or do anything else. So now I've got this spring. Now, if you haven't modeled a helix yet in Onshape, we use a cylinder as construction or a reference for your helix. So that's how this spring was built. It's a helix that's driven by this cylinder. And the neat thing about this is I now have a great reference right in the middle of this hole for a mate connector. Now, one thing I want to point out is you can use almost anything as a reference for a mate connector. So that's what I mean by kind of a Swiss Army knife. Think of a mate connector as just about, being able to almost accomplish anything when we talk about odd mating scenarios. So just think about, mate connectors as a tool to handle those odd situations and also to speed up repetitive tasks. I'm going to show you an example of that in just a bit. But how do we create one? So I'm in my part studio. I've got the mate connector command here in the toolbar. I select it. And as I move my cursor over the part, you'll get that very similar, mate connector feeling as when you were mating parts in an assembly. So as I move my mouse over the part, you'll see all these different points appear. I want a mate connector right at the center of that cylinder, right at the end, right in the center, just like so. Okay, so I select it. Important to point out, especially in this example, I actually have two parts here, the cylinder and the spring. The cylinder is just for construction, but it's important to point out, make sure to define the owner part. In this case, I have two parts. I need to make sure to tell it the spring is what owns the mate connector. Right? So I select the spring, green check OK, and now I've got a custom mate connector in my part studio. And the neat thing about this is now when I jump back to that assembly, I have a reference. I can select fasten, select the mate connector that I inserted, select the mate connector I want to attach that to, and you're good to go. Right? You've mated the parts together. So I just like to show that example. If you've got one of those scenarios where it's not entirely clear cut, what is your mate connector? Or maybe you don't have a good reference for a mate connector, you can insert one. And it's also very useful in a number of different situations where, maybe I want to orient it a certain way every single time I insert it. And I don't want to have to enter a value every single time. I can create a mate connector and use that as my reference and save myself from having to type in the same values over and over again. So there's a number of reasons for custom mate connectors, not just if you don't get a good default one. But that's a custom mate connector. Again, you could do it at the part studio or the assembly. The key thing about doing it at the part studio is it goes wherever the part goes. So very important oftentimes. All right, so we've covered many of the different mate types. I have one left to cover. We've covered group. We've covered custom mate connectors. What I'd like to show you next is a few different relations. Now, we have a few different relation options I'm going to cover here, so give me just one moment. The first I'd like to show you is just some simple gears, and I think this is one of the more common examples where I have one thing rotating and I want another piece to rotate relative to it. A great example is a gear. Whereas I spin this, I'd expect the other to move at a certain ratio. The key thing with all relations, it doesn't matter if it's a gear relation, rack, pinion, screw, or linear, is they're dependent on you having existing mates already established. So in this case, if you look closely, these gears are attached to this housing with a revolute mate. So you'll see a revolute mate for each gear. That's the key, because in a gear example, we reference two revolute mates. Okay, so in a gear relation, you select gear relation from your toolbar, then select the two revolute mates that define the gear's locations. Then all we do is define a ratio. Right? So for every one rotation of one, the other moves at 1.25. Right? I hit the green check, and now when I drag, give me an example here. Okay, we'll do revolute 1 and 2. One more time. 1.25. Define my ratio. Now you can reverse it. So if you find that it's going the wrong way, you can spin it the other way. But now when I grab and drag, I can see that one's moving relative to the other. So very important thing to point out. Now, a tip. In general, you'll notice, in this case especially, that the teeth aren't perfectly meshing. There's a few ways you can handle it. One of the first that I want to point out is make sure that your gears are going the right direction. Okay? If that's not the case, then what you may want to do is orient the gears before you mate them. And this is another example where I might edit a mate connector and rotate it. Right? Rotate it maybe 8-9 degrees until the teeth perfectly mesh. This is a little bit more specific to those building gears, but I just want to point that out. You really want to get the teeth meshed correctly and then define your gear example. And you can do that by editing the mate connector and twisting it until the teeth line up. Okay. So that is a gear relation. The key thing with the gear relation is keep in mind it's dependent on having 2 revolute mates. Those revolute mates define the location of the gears. So let's move on. The next one in my list is a screw relation. So for this, we'll jump back to the machine vise. So back to the assembly I was working with earlier. And of course, the idea behind this is I want to be able to spin the handle and drive the jaw in and out, just like a real vise would behave. And the key thing there is, of course, the screw relation. So I can select screw relation from the toolbar, then select the mate. Now in this case, a screw relation is dependent on a cylindrical mate. So if you look closely there, you'll see that the spindle of this assembly is tied to the base with a cylindrical mate. And all we're doing here is we're saying, okay, for every 1 rotation of that cylindrical mate, move in a linear direction this amount. Okay, in this case, 1/2 inch. So I can hit the green check OK. And now when I spin, I get driving motion like you'd expect. It drives it in and, of course, drives it back out. Right? The key thing there, keep in mind that it's dependent on the cylindrical mate, and then you use it as a reference and define the amount of linear travel that you want for every rotation. Okay? All right, so that is the screw relation. The next one in my list is a rack pinion relation. So we'll jump into the arbor press here. So here I have a simple example of an assembly where I want to be able to spin the handle and drive this rack gear up and down. Right? A typical rack pinion type scenario. The thing to keep in mind with a rack pinion is it's dependent on a slider and a revolute mate. So if you look closely, I have the pinion gear defined with, the rack gear defined with a slider mate, and the pinion gear, of course, defined with a revolute. So the slider means it can move up and down, and the revolute means the handle is free to spin. So what we're doing with a rack pinion relation, right here in the toolbar, is defining a ratio. So for every, for every 1 rotation of that revolute mate, I want you to move this amount. Okay, in this case, we'll say for every 1 rotation of the handle, it should move 2.25 inches. Again, keep in mind with all these relations, if you find they're going the wrong way by default, you can reverse them. But if I hit the green check, you'll see if I grab and drag, I get the relation. Notice it's opposite. It's going the wrong way. So this is a great example where I'd edit, reverse direction, and then I'd get the correct behavior, right? I'd get movement like I'd expect. Okay. So that is a rack pinion relation. The key thing to keep in mind with a rack pinion relation is it's dependent on a slider and revolute mate. And then you just define how much linear travel would you like. The last relation that I have on my list is the linear relation. So if I select linear relation from the list, this is an example where I always like to show something along the lines of linear guides. A 3D printer is a good example, or maybe a milling machine, for example, where I have these guides that slide along a track, and I need them to be tied to each other. So if I look at this guide and I move it up and down, I want this guide to move at the same exact rate as this guide, and they're not. And this is a great example where the linear relation allows me to tie those two together and have them move together. So I select linear relation from the toolbar. Now the key thing with a linear relation is it's dependent on two slider mates. So in this case, these guides locate on the rails with a slider mate. And all I'm doing is I'm saying, okay, select each slider mate and set my ratio. Now, I want them to move at the exact same speed. But if you didn't, if you wanted one to move twice as fast as the other, you can specify that here, or half as fast. You can tweak the values. But important thing to keep in mind, this is a ratio between the relations. In this case, I want them to move at the exact same rate. So I leave that at 1, green check, and now if I grab and drag, you see that both of them move together. Okay. So again, all we're doing is we're tying those two slider mates to each other so that when one moves, the other moves with it. Okay. So those are a list of the relations. Now, there's one more thing I want to discuss before we get into the last thing of today, and that's the tangent mate. The next thing I want to discuss is what we call snap mode. And snap mode is just a very fast way of applying mates. So real quickly, let's delete that last fasten mate that we created in this assembly. I'll just right click and delete it. And you'll notice now that that's been deleted, if I move my swing arm, it's free to float, right? It's no longer attached to the end of that plunger. Now, snap mode is just a very fast way of applying mates. So if I inserted a dozen parts in my assembly and I just want to real quickly put them together, I might turn on snap mode and just start adding mates. So again, the idea behind this is all about speed, doing it quickly. Now, I'd like to show you how this works. If I select snap mode, and then I move my cursor over, I want to snap. I want to do the same mate we did before. I want to attach this point to the plunger. But watch the difference. If I move over here, instead of left-clicking each point, I just left-click and drag one point over another point. It automatically mates the two. So instead of selecting mate, selecting the mate connector, and defining OK, you can just turn on snap mode and drag one mate connector over another and add mates very quickly. So that's all snap mode is about, really getting stuff done very quickly. A couple things to keep in mind about snap mode. It's on until you turn it off. So it's an on-off thing. It's like a mode that needs to be engaged or not. So if you're done adding mates, you'll want to make sure to turn it back off. Now, a bit of a tangent, kind of a off-topic thing here, but I didn't mention this earlier. We can add offsets between the mate connectors. So a commonly asked question is, well, what if I wanted an 1/8 of an inch gap between these two parts? That's a great example where I can add an offset, enter a value, and it will create a small offset between the two mate connectors, giving you that small gap. So another commonly asked question, is there a way to add a distance between two things? And the offset option gives you that capability. All right, now as I mentioned before, keep in mind snap mode is on until you turn it off. So if I start moving my mouse over other parts, it assumes that you want to continue mating. Again, very quick, but if you're just trying to move things around, if you're trying to do something else, you'll want to turn snap mode off. All right, so one of the last things that I have for you today, we have just a few minutes left, is a newly released tangent mate. And this is a very cool example. I like to show this example of a pin traveling through a maze here, but a common example that I always like to reference too is a cam. So if you have a cam actuating a valve, for example, or if you have some kind of cam movement, you can use a tangent mate to accomplish this. Now, a tangent mate is a bit different than the other mate types. In the other mate types, you select a mate connector, a point on each part. With a tangent mate, you can use edges or faces. You can even use a vertex. So you can use faces, and I think that's the big thing I want to stress here, because it's very easy for me to select a face on the pin, for example, and select a face on the inside of this slot, and now the two are mated together tangent. Now the big thing here is it automatically recognizes all the propagation, so I can see this thing will now stay inside of that slot and even hit the limit, right? It'll hit the outside and stop, right? So definitely worth checking out the tangent mate. You can even use faces or edges as references, but it maintains that tangency throughout its travel. Another example I like to give is a cam. If you're familiar with an automotive engine or a traditional gas engine, I should say, a cam is a way of actuating valves, and there's lots of examples of cams I could give, but a tangent mate is a great example of that. So, newly released. If you haven't checked out tangent mates, I definitely recommend it. Very powerful tool. So that is what I had planned. Now, there is one last thing that I always like to mention, and this is just a brief mention. I don't necessarily have an example of it. But you can define sub-assemblies and even top-level assemblies in Onshape. So as I mentioned before, you can insert sub-assemblies into top levels, but you can actually build new sub-assemblies on the fly. So I can move to a new subassembly and even create new subassembly right inside of this assembly. So if you have one of the scenarios where you've inserted a few parts and you realize, that should have been its own subassembly, you can build that on the fly, right inside of Onshape. All right, so that is what I had planned for you today. We have just a few minutes. I'm going to stick around and answer any questions. Speaking of which, does it work with a slot size larger than the pin diameter? And the answer is yes. It's using the reference between the two and centering it. So definitely try that out if you haven't already. But yes, it will work with a slot size larger or a pin size that doesn't exactly fit inside of it. So something you'll want to keep in mind. Another commonly asked question that we get is, well, how do I know if it's colliding, or is there any way of knowing if two parts clash? And the answer is yes. You can actually run section view. I don't have a clash in this example. In fact, let's jump back to and create a clash here just to show everyone. So I'm going to pull this plunger almost out of the cylinder here. And if I select a face and we do a quick section view, I can grab this, pull it back, and you'll notice the red. The red is clashing. The red is interfering, right? So the plunger is interfering with the cylinder anywhere where it's red. And so it's our interference detection, type tools are built into the section view. Select section view, drag it, and if you see any red, those are conflicting or interfering parts. Okay. So just an aside, but important thing to keep in mind, we do have the ability to recognize clashes between parts, and it's integrated into section view. Okay. All right, so that's what I had planned. Again, I'm going to stick around and answer any questions, but just real quickly going forward, if you haven't tried Onshape in your professional work, we really encourage you to do so. Try Onshape in a professional project and let us know what you think. There's a feedback mechanism built into Onshape that makes giving us feedback very easy, and we really encourage you to do so. We're working very hard to build the next generation of professional 3D CAD applications here, and we really, really encourage you to try it out and let us know what you think. Also, if you haven't already, invite others and share your document. I mentioned it before, but there's a big share icon in the top right corner. You click share, enter their email address, define their permissions, and hit share. So it's just a few clicks, and they could be looking at the same model you are in real time, right? So you don't have to email files back and forth. You don't have to do Dropbox or any of those kinds of things. You can use Onshape to accomplish all of that. So invite others, share your documents. Also, the last thing to mention, if you've been using Onshape a while, maybe you're interested in meeting local users, we'd love to hear from you. If you're interested in establishing your own user group, we'd love to help you out. So that's what I had. I'm going to stick around and answer any questions, but that's it. Thank you, everyone, and have a good day.